Okay, so first chapter we are starting with this semester is something called rational expressions. Rational expressions. You've seen rational expressions before. You just didn't call them rational expressions. Rational expressions are no more than fractions that are polynomials. So you've seen fractions many, many times. Numerators on top, denominators on the bottom. That's what we call them. But the fractions we see, they're going to look a little different. That's it. Okay. And we'll get to them. The first two, you see the first two, A and B, example number one, those are regular fractions that you've seen going back to elementary school, right? In fact, the first thing I ask you to do is reduce it, simplest form. So 12/15ths. I know a lot of you could do that in your head. You can reduce them in your head. That's fine. Keep doing that. But what is the thought process? Like, what am I looking for when I reduce a fraction? There you go, GCF, right? What is the biggest number that goes into 12 and 15 evenly? And yeah, it's going to be 3, right? So in your head, you're like, okay, this is 3 and this is a 3, right? So 3 times what makes 12? 4. And 3 times what makes 15? So in your head, you're like, hey, they both have 3s. So we can cross them out. But I have a different way of crossing them out. Instead of crossing them out, what is 3 divided by 3? 1, right? So I cross them out using a giant 1 to help me remember that. Okay. So all that's left over is the reduced part, 4/5. Right? That's all we're doing today. Okay. We're just reducing fractions by looking for giant 1s. Okay. So let's do the second one. 8 is the biggest number, right? So 8 and 8. So to make 24, 8 times what? 3. And to make 32, it's 8 times 4. So I see that they both have 8s, right? So anything divided by itself makes a 1. So what's ever left over, 3/4. Is there anything left? Is there anything that 3/4 has that I can divide them both by? Does 3/4 have a GCF? Nope. So that means I'm done. Okay. That's all we're doing today. Okay. That's all we're doing today. The steps that we're going to use to do the ones from today, factor the top and the bottom. Factor means divide, just like we did. We broke them up into 3 times 4, 3 times 5. Okay. Today, what we're going to have to do is we're going to have to use, if it's a binomial or if it's a trinomial, we have steps, right? We've done that before. Factoring those guys, we've done those before. We're going to do them today. GCFs, just like we saw earlier. Once we do that, once we do step 1, we're looking for giant 1s. We're looking for things that cancel out on top and on bottom. I call them giant 1s because when you divide them, they make a 1. And they go away. Okay. All right. So the first one that we're going to see is letter A. It looks kind of like what you did on number 1, A and B, but it's got some X's, right? So let's take a look at it. Don't worry about the X's yet. Let's just do 15 and 20. What do 15 and 20 have in common? So let's rewrite them. To make 15, I need a 5 and a 3. To make 20, I also need a 5, but I need a 4. Giant 1s? 5. 5 divided by 5 makes a 1, right? Now let's go to the X's. I have 1 X on top. On bottom, how many X's do I have? I write them like this, right? X cubed means X times X times X, right? Do I have anything else that's the same on top and bottom? Those cancel out. Now, do the other 2 on the bottom cancel out? No, because there's nothing left. There is nothing left to cancel them out. There is nothing here. So the last thing to do is multiply it. It's just go straight across. On top, I have a 3. On bottom, I have a 4x to the second power. Done. No more giant ones. Yes, sir. Yeah, you can do that. Yeah, that would probably be more efficient. But yeah, absolutely. Yeah, that help speed things up. Okay. Letter B. Letter B, what is the greatest common factor? Let's do the numbers first. 9. So 90 is 9 times 10, right? 99 is 9 times 11. Giant 1. Now let's do X. Bottom doesn't have any X's. The denominator does not have any, so I can't write any. So I can't cancel out any of the X's because there's none on the bottom. So the top is 10x to the second power. The bottom is 11. I'm done. Okay. Letter C. Letter C. 15 and 16. What's the greatest common factor? What is the biggest number that goes into 15 and 16? Evenly. 3 goes into 15. It doesn't go into 16 evenly. 4 does, and 8 does. But those don't go into 15 evenly. 1 is the biggest, right? So it's just 15 times 1 and 16 times 1 times x. The 1's cancel out, but does that do anything? No. So we're just left with the same thing we started with. So what does that mean? It means it's already simplified. The question was already simplified. It can happen that way. Sometimes nothing will cancel out. That's fine. It's already done for us. Okay. Okay, so if it's already simplified, great. Okay, just put the whatever it was. So now turn it over. Look on the inside. Look at example number 3. Hopefully some of those things look familiar. So I know there's a division sign, but look beyond the division sign. Look at the top and look at the bottom. Do those things look kind of familiar to you? Yeah. We've seen them a lot, right? We've seen those a lot. So how do we factor the top? We do, yep. We do those steps right there, right? Set it equal to 0. Factor out GCF, ABC. Then do it that way, right? Let's do that. That's what we're going to do to the top and we're going to do the bottom. Okay, so the top. There is no, all right, I should say the top doesn't have a GCF, right? The bottom doesn't have a GCF. There is no number that I can divide them all by, so I skipped that step. So the top, A is 1, B is -7, C is 6. So what numbers multiply to be the top, 6, but add to be the bottom, -7? -1 and -6, yep. So that means the top, the numerator becomes x minus 1, x minus 6, right? Do the same thing to the bottom. Okay, what are the two numbers that multiply to be 4 and add to be -5? -1 and -4, right? Now they share -1 in common. So I'm going to line them up like this. I'm going to say -1 and -1, and then the other one's -4. What cancels out? There you go. Yeah. Those are exactly the same thing. Difference of squares. Or sorry, giant ones. Okay. So I get x minus 6 and x minus 4. Okay, so I'm going to show you something that I see a lot, but I shouldn't. I see people doing this. Oh, those cancel out, right? The reason they don't cancel out, that's wrong. The reason they don't cancel out, this is as far as we go, is because it's not x and x. It's x take away 6 and x take away 4. So it's a number. I don't know what that number is, but take away 6. And then if I have that same number down here and I take away 4, they're not the same number. One is take away 6 and one is take away 4. So that's why I can't cancel anything out anymore. Okay, I'm done. Done with that one. Simplified as far as it can. Okay. Do letter B on your own. I'll give you 3 or 4 minutes. Do letter B. Okay, so I did ABC for the top and ABC for the bottom, and that's what I got. I see that they both have a minus 2. So I try to put them, line them up, but let's say I didn't do that. Let's say I did it like this, because some of you might have done it like this. Can I still cancel out x minus 2's? So can I still, even though they're not right directly on top of each other, can I still cancel out the minus 2's? The answer is yeah, right? It's just preference, right? I chose to do it that order, but couldn't you do it this order too? Yeah. I like to do it this way because it reminds me these are going to cancel out, but you don't have to do it that way. Okay. So that leaves x plus 5 and x plus 1. Okay. All right. So I want you to try letter C. Try letter C. I'll give you a hint. You're going to have to do something before ABC. What are you going to have to do before ABC on this one? GCF. Yep. They both have GCFs. You've done that plenty of times before. Once you do GCFs, then you can go to ABC. And I'll let you finish. Okay, so for the top, I got a minus 7 and a plus 6. So remember, the x has to stay in front. I get a minus 7 and a plus 6. The bottom, I have a 2 in front, so I got to write that down. I also have a minus 7. So I'm going to minus 7s. I'm going to line up those minus 7s to make it easier for me. And then I have a minus 3. Okay. So I got a giant 1, or minus 7 and minus 7. So when I write my final answer, I need the x in front with parentheses plus 6, x plus 6, and then a 2 in front, x minus 3. Since there are no more giant 1s left, that's my final answer. That's how you would type it into Delta Math, with parentheses and division signs, just like that. Okay, you would make it look exactly like that. Okay, because those are the things that don't have giant 1s. They don't cancel out. Okay. All right. Okay, let's look at the last page, and then we will be done. So example 4, letter A. So doesn't this one look like the top, I should say, the numerator? The top, just the top. Don't look at the bottom. But doesn't the top look like something we've done before? It's a trinomial. So do that. Factor it. Use the steps that you've done to factor the top. Let's see what we get. Don't worry about the bottom. We'll do the bottom together. Okay? But just factor the top, just like you have before. So what are the two numbers that multiply to be 28, add up to be negative 11? Thank you. Perfect. So I got a minus 7 and a minus 4. Okay. That's the top. That doesn't change, right? Now let's look at the bottom. The bottom is different because it's not a trinomial. It only has two terms. It has two terms, x cubed and negative 4x squared. So since it's not a trinomial, we have to look at our list of binomial steps. Okay, so the binomial steps say something different. Set it equal to 0. Skip that step. Factor out a GCF. So does the denominator have a GCF? Yeah, they both have what in common? What can I divide them both by? Yeah, x to the second power, right? So I'm going to have an x to the second power. When I take away 2 powers of x, I got an x to the first power, or x by itself there, minus, what do I have left over there? Just a 4, right? I took away 2 powers of x. Okay. Difference of squares. It's close. This guy is close. If there was a squared here, it would be difference of squares. But it doesn't, so no difference of squares. Squares on the outside. Squares got to be on the inside for it to count. Okay? Giant ones. Is there anything that can cancel out? Yep, do it. Do it right. Sorry about that. Okay, so those guys cancel out, right? So what's left? X minus 7 and then x to the second power. Done. Okay. All right, let's look at letter B. The bottom. The bottom is a trinomial. So do that. Do that right now. What is the trinomial going to be on the bottom? Are some of you getting good that you can do it in your head? You don't have to do ABC. Can some of you do it like right now? If you can, do it. If you need to do ABC, do it. Okay? But you'll get good enough, trust me. We'll do this enough where you can do ABC in your head. You'll go, oh, x minus this and x plus this, or x minus this and x minus that. So I need the two numbers that multiply to be 5, or multiply to be 10, add to be negative 7. Perfect. Thank you. Negative 5 and negative 2. Good. Perfect. Okay, bottom's done. Been factored. The top again is a binomial. Okay, so we follow a different set of rules for that. Does it have a GCF? Does the top have a GCF? No, doesn't there, so we skip that step. Is it difference of squares? Yes, it is. Okay, difference of squares. How do we know it's difference of squares? It's a binomial. Mhm.
Because there's a square, there's a minus, and 25 can be divided into smaller numbers.
It's on our list, right? 25 is on our list of perfect squares, right? Because it's 5 times 5. Also, 1 right here, the number in front, 1 is also on our list. Okay, all of that's true. So it's difference of squares. So what is it going to break down to be? Remember from last semester? What is it going to break down? X minus 5 and x Good. Good. These guys done. Okay. X plus 5 and x minus 2. Okay. All righty. All right. So let's look at the last one. Let's look at the last problem here. Top. How many terms does the top have? One term. So it kind of looks like the front, right? The front page that we had kind of looks like one of those guys, right? So how did we break down those guys? We said what times what makes 7, right? We broke it down. So how do I break down 7? It's the only way, right? And x is just x to the first power, right? The bottom. What is the bottom? Is it a monomial? Has it got one term, two terms, three terms? Right? Right? It's got two terms. So we follow those steps. Okay? So the person who's closest to you, I know there's some people don't have elbow partners, the person closest to you, tell them what you're going to do. How are you going to simplify the bottom? Okay, tell them right now, tell the person closest to you how you're going to do that. Okay, so do it. Now that you know, do it. Whatever you said, whatever you heard, finish that out and we'll do it together in about 2 minutes, 3 minutes. Okay, so one of you guys, or you guys that were talking about it, what do I do? Tell me what do I do? GCF, right? So what is the GCF going to be for the numerator? Denominator, sorry. 7, definitely a 7. Is there anything else? Good. 7x. And then what's left? I want to divide them by 7x. Plus 7, right? Reverse distributive property. Okay. Giant ones. Anything cancel out giant one? This one's kind of a tricky one. Yeah. Yeah, look at the sevens. The seven's on the outside, not on the inside. The seven's on the outside of the parentheses. That's just a regular 7, right? So the sevens, not this guy here. This guy here is a part of something else, part of something bigger. Can't be reduced there. How about the x's on the outside? They're both on the outside, right? They're both divided by each other. So those make kind of a sideways 1. So on the bottom, I get x plus 7. Here's a tricky question. What do I get on top?
0.
So I heard 1,
0.
0. Anyone say anything different? What do I get on top? Say it out. Say it louder. So there's nothing. So 0. Oh, okay. So x plus 7 moves to the top. Here's the thing. If you divide something, anything, since it's easiest to think of this, let's take a pizza. Who doesn't like pizza? If you don't like pizza, think of it as a cookie. If I divide that thing, divide it by 2. Let's say I divide it by 2. Gone. Divide it by 2 again. Gone. I'm kind of getting what I'm going, right? Divide it by 2 again. So the shaded parts are gone. Already been eaten. If I divide something enough, is there ever going to be 0 pizza left? Yeah, because if you cut something so small, right, you might need a microscope to see anything there, right? You might need a microscope, but theoretically, when you divide something, you never get nothing left. There's always going to be something there. It's called a half-life. You guys, in I think chemistry, they teach you about half-lives. If you take half of something or divide it, even if I divide it by 4, divide it by 5, divide it by anything, there's always going to be something left. So what am I getting at? The top here is never going to be 0 because I'm dividing. There's always got to be something left. What is left? Well, what are these ones? These are ones, right? So 1 times 1 makes what? So there's always going to be a 1 on top. There will never be a 0. Okay, there will never be a 0 because you're dividing. Okay, anytime you're dividing, there's always going to be something. Okay, all right, people in the back, if you are in the back, could you get some tape for the for your row? Tape it in.